Hey guys, so today we're going to talk about how to do two-column proofs specifically just for algebra. Now, real quick, let's talk about the different parts of a proof. So in a two-column proof, there are two columns, hence the name. One is statements and one is reasons. Statements is what we know, reasons is how we know it, and they're related. One leads directly into the other, so this should flow nicely. In algebra proofs, there's only a specific amount of reasons we would have, and these are listed up here. Real quick, just to go through them. Addition, subtraction, multiplication, and division properties of equality. That is when you do something to both sides of the equation. So here you're adding to both sides, subtracting to both sides, multiplying and dividing. Distributive property is when we have parentheses and we literally distribute what's outside inside, so multiplying, but with parentheses or brackets. Simplifying, or CLT, which is just combined like terms, that's when we are just adding things on the same side or subtracting things on the same side of the equation, so combining like terms. These are not just applicable to algebra, they also work for geometry. Now, reflexive and transitive we're not really going to use right now, so I'm not going to go over them too much, but symmetric is something we will definitely use with these proofs. So symmetric deals with two different things that are equal to each other. So usually what happens is, if A is equal to B, through the symmetric property, B must also be equal to A. So we use this to switch our equations when it says 11 equals X, but the proof says we need to prove X equals 11. So you can switch them using symmetric. So let's take a look at an actual proof. Starting with this first one here. Whatever was given is always your first statement or reason, every single time. So my first statement is whatever comes after the word given. So I'm going to write 3x equals negative 12. That's what I know. Now, how do I know it? It was given. So that will be your first line for every single proof, both algebraic and geometric. Secondly, we need to prove x is equal to negative 4. Now, this is a one-step equation, hence why the proof is so short. You want to figure out, what do I have to do to get x by itself? Well, to get rid of that 3, all we have to do is divide both sides by 3. So for example, I'm dividing both sides. Here's the thing though, with a two-column proof, you wouldn't write that work in there. This is not something written. Instead of writing it under the equation, we explain in words what we did. So if I'm dividing by 3, that's the division property of equality. If I divide both sides by 3, I'm left with x is equal to negative 4, which is what we wanted. Whatever you have to prove should be the last statement. If not, then you are not done with the proof or you did something wrong in between. So let's try something a little tougher. Let's take a look at something like number 6. First thing I'm going to write is the given. So in the statement, I write the equation. 23 equals 4x minus 1. In the reasons, I write the word given, because that's how we know that this equation exists, because it was given. Now this is a two-step equation, so first thing we got to do is get rid of that negative 1. So I'm going to add 1 to both sides, leaving me with 24 is equal to 4x. Now since I added 1 to both sides, that is the addition property of equality. Next, to get x by itself, I need to divide both sides by 4. So we're left with 6 is equal to x. Since we divided, that is the division property of equality. Now here's the problem. I solved the equation, x is alone, but my proof is not matching the end of my proof. That means I'm not done. So I know the end should be x equals 6. We got to figure out, how can I flip them? That's where that symmetric property comes in. It allows you to switch the two sides of the equal sign. So I can change this to x equals 6 because of the symmetric property. And And that is pretty much how we do algebraic proofs in geometry.